Hey guys, Mr. Kowalik here. Today we're going to look at ballistics in our forensics course. You need to follow in your notes and watch this video for the notes and fill them out as we go. Okay, so let's get started. The world of ballistics revolves around firearms. And in this image, you can see here a firearm being discharged and a projectile coming out the front of it. Ballistics goes into a lot of aspects of firing guns and what happens to the bullets as they come out of them. What we're going to focus on is really just that projectile and recovering it from a crime scene and what we can do with the evidence, um, and how we can connect it back to a firearm and possibly back to somebody who might have been using that firearm. So let's look at the vocab. Ballistics is the science or study of the motion of dynamic projectiles. Some more terms. The barrel is a portion of a gun or firearm through which one or more projectiles travel when the gun is fired, usually round and tubular. A gun's barrel may or may not contain rifling, which are grooves which impart a spin on a bullet and or other projectiles. As you can see in this image over here, the bullet is spinning because of those grooves that are on the inside of the barrel called rifling. Without them, the bullet would not spin. Cartridge is a container designed for insertion into a mechanism. In the case of ammunition, a cartridge container contains a gunpowder or powder charge, a projectile, and has some kind of primer cap that is struck by a firing pin, enclosed in a case to hold all the components. As you can see, there's a variety of different cartridges here that can be inserted into a gun. They're very specific as to which cartridge fits in which gun. Okay, this one's easy. A handgun is a gun designed to be held by one hand. Typically, they're called pistols or revolvers. Here's a classic case, one of the originals. This is a revolver, holds 5 or 6 rounds in this chamber here. It can be fired one at a time. Here's a more modern day pistol, not a revolver. This is a pistol. The bullets are carried in the handle in a cartridge that can be quickly unloaded and loaded. And there, of course, is the finger pistol. The rifling is a series of evenly spaced spiral grooves cut into the bore or the inside of the gun's barrel. As you can see here, this one's been cut open. Normally it's closed. And you can see those grooves really carved into there. They're cut in a spiral pattern to partake spin on the bullet as it leaves the rifle. You can see that down here as well in this cross section. And you can see it down the barrel straight here. Snub nose pistol or snub nose revolver basically just has a shorter barrel. Again, that's going to give it less accuracy and less range. Speed loader, term used in ballistics for a mechanism that fills all the chambers of a revolver at once. So when we talk about forensic ballistics, we talk about pistols, which we just went over. We also talk about shotguns. That's another type of gun that can be used for forensics, and rifles. All of those can be used in any kind of crime, and the cartridges and the bullets that come out of those can be different and analyzed to see what kind of rifle or gun it was fired from. The cartridges here show that. We see a pistol cartridge, quite small. One comes out of here at a time. We see a shotgun cartridge called a shell. Looks quite different than a pistol. And then this is a rifle cartridge, much, much bigger, longer, and different shapes. So at a crime scene, when any of these guns or the evidence of guns, which would be the cartridge, are recovered, we can tell what kind of firearm it was discharged from based on the shape. The cartridge itself carries a lot of evidence, so we need to look at the cartridge a little more closely. Starting at the back, the primer or primer cap is where it's where the firing pin strikes and causes a small, very small ignition or a little burst of energy that's going to light the propellant up. This could be gunpowder. That's going to explode and send the bullet down the tube. And as you can see here, that animation, you see the explosion of the gunpowder sending the projectile down the tube. Now, the primer cap and the side of the bullet where it's making contact with the rifling is where we can get a lot of evidence. I'll show you that in a moment. The rifling down the barrel of a gun, like we said before, gives the bullet spin. And as this quarterback up here is throwing the football, we know that the spiral of the football causes it to go farther, more accurate, and easily catchable. The same thing happens to a bullet. It's going to be more accurate and it's going to go a lot further if it has spin to it. If you throw a football without spin, it tumbles, doesn't go far, it has no accuracy. The same thing would happen to a bullet without the spin. So the rifling is in the barrel of the gun. As the bullet passes down the barrel of the gun, it's such a tight fit that the rifling is actually carved into the side of the bullet as it goes down. In the forensics world, the grooves are carved into the side of the bullet, and the lands are the parts in between. So grooves and lands. If we can recover a bullet and compare it to another bullet that was fired out of a gun, and those grooves and lands match up, we can assume that this bullet was fired out of that gun. A little history of handguns. Originally, the original guns were revolvers. They're dependable for the police. They always fire. And they're really slow to reload. It was a downfall. Since then, newer pistols were created, which are much faster to reload because of the invention of this cartridge. Cartridge holds 12 or 13 rounds, can be inserted into the handle quickly and reloaded. So they're faster firing and faster to reload. The forensics world, once that gun is fired, the shell is left behind from the cartridge and the bullet is fired downrange. We can look at the shell to understand something about the firing pin inside the gun. There are three differences that we look for in the firing pin. We look for the position of the dent as it hits the primer. Position is important. You can see here this position of the firing pin is kind of to the left and down a little bit, where this one is more centered. The depth of the impression left by the firing pin, some are shallow, like this one, and some are quite deep, like this one over here. And then the shape of it, whether or not they're oval, like this top row, or round, like this second row here. And then these have a convex and concave impression in them from the firing pin, which gives us an idea that there were three separate firing pins and they could be linked to multiple different guns. And then this is a close-up picture of those lands and grooves. Again, they're the marks left by the rifling in the barrel of the gun as the bullet is fired downrange. Those lands and grooves can be matched to each other. What a forensic scientist would do if they were looking into the lands and grooves is take close-up pictures of an evidence, called the one on the left here evidence, and then the one on the right would be the same type of cartridge fired from a gun that they were trying to link the two bullets to. If we can overlap these pictures and match them exactly, the spacing between them, the width and the depth of all the lands and grooves are very specific to each barrel. So it's highly unlikely to have the exact same patterns on multiple bullets. So you can use the lands and grooves to help identify whether or not a gun was fired or a bullet was fired out of that gun. So that's it for the ballistics presentation. Make sure to go through your notes, and I'll talk to you later.